First of all, so I could pull this model out on the next lab practical. Okay, I could pull this model out. I might use pictures though that are similar to it, so don't get too locked into this model. Also notice too that these things are removable, so don't expect to see this whole model in one piece like this. You'll probably see things removed. But let me walk you through it anyway. So this would be considered interphase at this point. Notice that you got the nucleus, here's the nucleolus, and then over here, all this other junk, this is supposed to be the chromatin. You can't really see the chromosomes yet. They're all sort of spread out, they're unraveled. So this is interphase. Also notice it must be early on in interphase because you only have one centrosome here. That's one centrosome. Then as you move over here, this is supposed to represent prophase. Okay, notice that by the time prophase begins, you have already copied your centrosome. So you got one centrosome here, you got one centrosome here. They're starting, if you can see, it's a little hard to see on this model, but there are dotted lines here. They're starting to form the spindle in between them. Notice that in the nucleus, you can actually see the chromosomes. These red things are supposed to be the chromosomes. So now you're seeing the chromosomes for the first time. Notice too that they've got more little sort of holes developing in the nuclear envelope, so the nuclear envelope is starting to disappear. Okay. Now, don't ask me why they did this on the model, but this is still prophase here, it's just a little bit further along. So notice the centrosomes are going to opposite ends. You can see the lines here, that's the spindle that's going to be forming in between them. Notice the nuclear envelope is disappearing even more now. Okay.
Is that the prometaphase or whatever? Prometaphase?
Oh, prometaphase?
Yeah.
Well, I think I would just call it like middle prophase. But you guys don't need to do that. Like, if you see this, you can call it prophase. If you see this, you can call it prophase. You don't have to say it's like at the beginning or the middle of. You can just classify it all as prophase. Okay. And then this still is prophase. It's just now the centrosomes are really far apart. You've got the full spindle forming, and you've got all the chromosomes laid out. Notice the nuclear envelope is almost completely gone now. It's disappeared. So all of those are prophase. What's this supposed to represent? That's metaphase. So they're all lined up in the middle. Again, they didn't want to draw all 46 chromosomes, but you can imagine all 46 kind of sitting single file there. So that's metaphase. Then as you get down here, what's that supposed to represent? So that's anaphase. Okay, they're being pulled apart. Now, again, don't ask me why they did it, but this here I'd still probably call this, whoops, sorry, not doing a good job here. Let me back it up. This would still be anaphase, it's just a little bit further along. Notice that you're starting to see the beginning of the cleavage furrow, right? So cytokinesis is kind of starting right here. That you can tell because of the cleavage furrow that's working in. So that's also anaphase. Then as you get over here, what would you call this? What would you call this phase? That's telophase. Notice, I think the obvious thing is, notice the nuclear envelope that's reforming around each of the sets of chromosomes, right? So this is going to be telophase. Notice the cleavage furrow is even deeper. And then this is also telophase here. You've almost completely reformed the nuclear envelope now. The cleavage furrow is even deeper. Eventually there'll be two separate cells, right? So make sure you know those phases, those names. The other thing though, I want to tell you one word that's on there that I didn't mention, asters. Asters, and they're going to be a little hard to see here, but I'll try to show you anyway. So here's the centrosome, there's the other centrosome. These are microtubules that are making the spindle, right? So that's the spindle that you have there. If you can see it on the model, it's a little hard to see. You actually also have microtubules that go in this direction, that come out the other way. So the microtubules that connect the centrosome to the cell membrane, those are called asters. And you have them coming off here, and then you'd also have it coming off here. The purpose of the asters is to anchor the centrosomes in place. When this spindle starts working, the spindle is going to need to pull the chromosomes apart. But in order to do that, you somehow have to have these centrosomes anchored, and that's what the asters do. They hold the centrosomes to the cell membrane. Okay, so again, you can kind of see the little dotted lines, but it's a little hard to see them. Those are supposed to be the asters. Okay. All right, I think that's, oh, one other thing I want to tell you. It says in your lab guide, where is it? Hold on. It says in your lab guide, on a microscope slide